Okay, it's almost time. So, before we try learning something new, a quick question to everybody. Whatever we learned or tried learning yesterday, was that okay to understand? Were you all able to follow it? Or was there something that was not clear? Everything clear? Okay. And I would request everybody to keep your videos on, okay? Because your face tells a lot of story. When I see your face, I can make out that okay, if whatever I'm saying, that you're able to understand or not. Yes, Gitesh.
What did we learn last class?
In the last class, we started learning algebra. Okay, so that is where we just briefly touched upon the concepts of equation, inequality, and expressions. That is all that we talked about, and that was at a very high level. You all remember? Everybody remembers equation, expression, and inequalities? Okay, good. So, Bhuvan. Cool. So Bhuvan also was not in the class yesterday because I know he had a chess tournament. So, just to do a quick recap, while we are waiting for who all is remaining to join. I think Adrik and Arab in the classroom, and who is missing here? Sanvi is missing, Cherry is missing, Mara is not joining today, and Gaushika is not joining. So basically we are waiting for Cherry, Advik, Arab. Do we see anybody here? Not here. Okay, alright. So let's start with a quick recap of what we did yesterday, and then we will continue from there. So, when we talk about algebra, as I was saying, you are dealing with a situation where you have some things that are known and some of the things that are unknown. Things that are unknown or to be determined, we mostly use terms like X, Y, Z, A, B, C, whatever. Some alphabets you use, okay? Something that is unknown will not say, okay, since this is unknown, let's assume this is 7. This is a constant. Okay? So, these are the alphabets that we use for assuming things which are known. And that is where you will see we use them quite a lot in algebra. You will see a lot of questions will say, okay, 5p plus 25b equal to 67. Nobody knows what is B. Is it B as in Binendra Kumar, that is me, or is it P as in a child named Tanvi? Yeah? So these are the variables that we assign. As I said, variables. Something that could vary or that could depend based on the situation. Okay? That is what they are called variables. So we things that are, come on, things that are not known, we assume them or give them some names and we call them variables and we solve for them. So that is what we will deal with in algebra. You guys might want to shift a little bit to this side so that I can see everybody's face. Something you can move, yeah. Okay. So, yesterday we talked about three things. One is called equation, one is called expression, and one is called inequality. Equation, inequality, and expression. Okay, settle down. Okay, this class is not for all the tug of war, all the arm wrestling we have to do, we'll do it outside the class. Okay? Give one to him. Give one to him. Give one to him. That's okay. Calm down. Let's not waste our energy for things that doesn't help. Everybody here. Alright. So, when we talk about algebra, these are essentially the three things that we will come across. One is called equation, one is called inequality, and one is called expression. You all saw me yesterday smiling without a reason. That is called expression. Meaning when you don't have an equal to sign, when you don't have an outcome. 5x squared plus 6y plus 17. There is no equal to sign here. Hello, Cherry. There is no equal to sign here. And this is same as me smiling without a reason. There is no equal to sign. There is no outcome. This is expression. When you look at something which is not 5 always. 7y squared plus 27 equal to 17. You have an equal to sign. You have a purpose. You have an outcome. It says if you add these two, this is what you get. You have an outcome. You have an equal to sign. That's why it's called equation. So I'm just doing a recap of what we did yesterday so far, and then we'll talk about one student is missing. She will not join today. So expression, equation, and then something called inequality, where you say 2x minus 17 is greater than 11. This is an inequality. This is not equal to. It could be greater than, it could be less than, it could be greater than equal to, it could be less than equal to. All these four scenarios where you don't have an equal to sign, this is called inequality. Okay? So far so good? Nothing to worry. Everybody here in the class. Okay? Alright. Now, who all knows what is monomial, what is polynomial? Oh, okay, no, you are seeing your classmates here, but pay attention. Pay attention. You don't have to like or dislike anybody.
Is there more to it? Is there like only one equation for algebra factors?
How is that question relevant right now?
Wait.
We have just scratched the surface. There is a lot more that we come to know. Okay? So, absorb it as you come across it, and obviously I'll take the question. Alright? So, now let's look at some more constructs of an equation or expression. Let's say, if I say 5x squared, or I say 4x plus 17y. Somebody has raised hand. Yes, Amoga.
So does an expression not have any equal sign?
No, expressions don't have equal to sign.
Yeah.
So like I was giving an example. When I smile without a reason, when there is no outcome, okay? If I come to this class, I smile for next 1 hour, don't teach you guys anything. That is just an expression, no outcome. No equal to. If I smile for 30 minutes, is equal to nothing. If I smile for 2 hours, equal to nothing. That's why it is expression, okay? Yeah. Yes, Vivan.
Sir,
Yeah.
what the question was that 1 plus 2 equals x. Would that be an expression or an equation?
No, you answered by yourself. You said 1 plus 2 equal to x. 1 plus 2 equal to x. Meaning when you are adding 1 and 2, you are getting something. There is an outcome. My smile did not have any outcome. That's why it was an expression. You said 1 plus 2 is equal to x. So you are getting something after adding those two. So you have an outcome. So that is not an expression. Okay? Yeah? And I know all the examples I am giving, those might be lame examples, but trust me, these examples will get glued to you. Whenever you see expression, when you don't see an outcome, when you don't see an equal to sign, you will know it is equivalent to my teacher smiling without a reason. There is no outcome. So that's an expression. Okay? Alright? Yeah. Coming back to, everybody is clear, right? Everybody is clear? So far? Okay. Alright. So now look at what I'm writing on the board. I wrote 5x squared, then I'm writing 4x plus 17y, then I'm writing, let's say, 25x plus 17y plus 18z. What is that? Still okay. That's fine. But now, when you look at these three things, okay? What is the difference between these three?
When I've done, like, we have like one number, one variable, and one exponent, one constant. The second one has a sign, so meaning like it's like.
Okay, you're not in the right direction, let me stop you. Okay, yeah.
So one doesn't have any signs and it's just symbol.
You're also not going in the right direction, let me stop you. No, you said one doesn't have any sign and all, okay? So that is not what I'm trying to cover actually. That's why I'm stopping you, okay?
Oh, okay. I forgot.
Okay, what is that?
One is a mononomial, one is a binomial.
Yes, that's what I said. Yes, correct. Now now you know why I was stopping you last time, right? Okay. Now, everybody here on the screen, this is one expression because there is no equal to sign. So this is an expression. This is also an expression because there is no equal to sign. And this also is an expression. This also has no equal to sign. But there is a difference between these three. Can somebody tell me what is the difference? I heard some difference here in the classroom. Anybody on the screen, if you guys know? All these people have some names. This is Ram, this is Sham, this is Mohan. I want to know what is Ram, Sham and Mohan here. Can you guys tell me? Yes, Vivan.
Are they expressions?
They all are expressions. I'm saying they have a name also. So this is a name Ram. I don't know what is Ram standing here for, so I'm giving a variable Ram. This is Ram, this is Sham, this is Mohan. I want you guys to tell me what is Ram, what is Sham, what is Mohan here. You know it. I'm just wanting everybody to know. Yes. So let me make it clear to you guys. Okay? Yeah, Vivan.
I was going to say variables, but then
So see, one observation is very simple that this has a constant and a variable. This has a constant, a variable and a constant. Here also you have constant variable. You have multiple things here. That part is clear. Now, you can see that this has one and constant and variable together. And there is no operations here. There is no plus minus. So, there is something one. In mathematical terms or in algebra, we say one term. This whole thing is called one term. Meaning, here you see 4x is one term, 174 is one term, 25x is one term, 17y is one term, 182 is one term. Every unique thing that is separated by an operation here is called a term in algebra. So any expression which has one term is called monomial. If it has two terms, this is called binomial. So if it has one term, it's called monomial. If it has more than one term, that is called polynomial. Poly stands for many. So that's why any expression which has more than one term is called polynomial. Now here, there is one more name given inside this. Since this has two terms, so two terms can be called polynomial, or there is a specific term for it called binomial, like you said. Now here you have three terms. Trinomial. Yeah? Trinomial or trinomial, whatever way you pronounce it. Trinomial is what I know. Okay? Now, polynomial, more than one term is polynomial. Two terms can also be called binomial. Three terms can be called trinomial or trinomial, the way you pronounce it. Or polynomial is a generic term used. Like we were saying, quadrilateral is a shape which has four sides. Within quadrilateral, you call one shape as rectangle, one as square, one as parallelogram and things like that. Likewise, polynomial is a generic term for an expression which has more than one term. However, a specific name for an expression with two terms is called binomial, three terms is called trinomial. Is it clear so far? Okay. Now, you guys will still have reasons to get confused. And let me clear the dust here. Now, if you look at an expression which has 5x and another expression which has 25x to the power 17, they both are single term actually. They both are single term. Everything that is separated by before or after any operation is called one term. Regardless of, even if it has x, y to the power 14, still this is one term. Okay? So, yeah, I'm coming to you guys, okay? I see that there is a question raised. I'll come to you. So what I'm saying is, if I have, regardless of the size of the value, okay? Size of the term, regardless of the number of exponents, it is still called one term, okay? So anything that is separated by a plus, minus or any operation sign is called one term, regardless of how many powers you have, okay? Yes, Dikshita.
What is the last term you told, like monomial?
Monomial, one term is monomial and more than one term is, there is a generic term for it called polynomial. Polynomial. Poly in Greek word means many, more than one. So polynomial means an expression with more than one term. Okay. Now within polynomial, when you have two terms, you can call it binomial. When you have three terms, you can call it trinomial, or you can use a generic term saying polynomial.
Okay,
Yes. I'm sorry, Vita. Dikshita, is that clear?
Yes, sir.
Okay. Yes, Amogra.
So more than two is more than one is polynomial?
More than one is polynomial. One is monomial, anything more than one is polynomial. And within polynomial is a much bigger bracket. Inside that, with two terms you call it binomial, three terms you call trinomial, four terms maybe quadrinomial, likewise. Okay? Yes, Siddharth.
Sir, I don't understand like a little bit, like.
Say that louder.
Sir, I didn't understand like a little bit of the. Yeah.
Okay, so that's okay. Not understanding is perfectly fine. That gives me one more opportunity. And that gives an opportunity to everybody else to revise. This is an expression which has only one term. Only one term. There is no plus something or minus something before and after. This is just one term. Okay? You can have one term like 5x or 16x square, or you can have a term saying 25x square y to the power 13. Still it is one term. Even if you have so many variables and constants inside this, still this is one term. Because your boundary of term is defined by the operation. Be it plus, minus, be it multiplication, whatever it is. Okay? This is your one term. Okay? So, any expression which doesn't have equal to sign with one term is called monomial. Is that okay? That one term monomial. More than one term is called polynomial. Many terms is polynomial. So your polynomial can have two terms, it can have three terms, it can have 100 terms, depending on how much complex problem you are dealing with. Okay? So 27x square plus 17y. This is a binomial or polynomial, whatever you want to call it. 6x square plus 17y square plus 24x plus 18y. This has 4 terms, 1, 2, 3 and 4 terms. This is a polynomial. So that is what we were seeing so far, okay? So one term is monomial, anything more than one is called polynomial. Within polynomial, if you have 2 terms, you call it binomial, or you can use the generic term, yes. Obviously, that will be part of what we learn. We are just starting. As I said, we are just scratching the surface so far. There is a lot more to do, okay? Alright. Now, so far clear, right? Everybody is clear? Basic understanding of terms, monomial, binomial, polynomials, binomials, trinomials, quadrinomials, pentanomials. Look, Sandri. Okay? So this, yes, Dikshita.
What is the 3 terms called?
Trinomial, like you say tricolor, a flag with 3 colors, or shape with 3 sides triangles, right? Same way. Yeah. Yeah? So trinomial. Okay? Alright.
Sir.
Now let's move on. So we just got a basic understanding of what are different types of expressions and the terms. Okay? Now, if I am looking at an expression this plus 6, this is one term. The difference between this term and this term is this term only has constant and this term has constant and variable both. Here x is a variable, 5 is a constant, and 2 is the power to the x, which is called exponent. This part is okay? I'll come to you. Let me complete. Okay? Now, here, there is one more thing that you guys would be knowing probably. If you don't, anything to the power 0 is how much?
1.
Is 1. Except this.
And 0.
Except 0 to the power 0, everything else in the world, be it 1, be it infinity, be it xyz, be it the name of my house, put a power to that 0, becomes 1. Okay? Alright, yeah, you have a question.
So you said that when it says it can be used as 5 variables, what if 6 to the power of 3? Will it still change? Or will it change?
What is that?
So when you said that 5x to the power of 2 is different than 6, what if it's 5x plus 6 to the power of 2?
The third way expression.
Well, if it's like 6 into 6 to the power of 2, which will
Doesn't matter. See, ultimately it's a constant. 6 to the power 2. What if I had 5 square plus 9? I can write 9 as well as 3 to the power 2. That doesn't change the basic definition of our expression or understanding of the expression. This is just a different value. That's it. Okay? Yeah. No questions so far? Or any questions? Okay, so let's move on now. So we just had a small diversion here, saying that anything to the power 0 gets me a 1, even if, except for the scenario when you are giving power of 0 to the 0. Okay? Yeah, that's what I'm saying. So 0 is the only number on which if you put a power 0, that will not be 1. Everything else with a power 0 will give you 1. Okay? So only keep that thing in mind. Now let's look at some more examples. Let's start the second flavor, okay? Or before I move on, if I have, let's say, 6x squared plus 5 as an expression, I can as well write this as 6x squared plus 5 into x to the power 0. I can do that. Because x to the power 0 gives me a 1. I'm just whatever I was showing you guys, I was just trying to relate it, okay? So tomorrow if you have to convert this into everything looking like an x, you can always do that if you want to, okay? Alright, now let's look at some more sample problems with the equations. Now equation, when I say, you are not looking at your teacher who smiles without a reason. There is an outcome. So this is an equation because this guy determines and tells you that yes, when you are working on this, there is an outcome. For every value of x, you will get an outcome. So that is why this is called equation. Now let me make you guys play with some equations. Let me give you guys 2-3 problems and I want you guys to solve it. And then, depending on how comfortable you guys are, I will determine how I want to go about teaching this, okay? So I have 3 questions for you to solve. 6x plus 12 equals 24. Okay, don't try solving, don't give the answer here, solve it, okay? And when I come to you guys, I will ask you how you are solving it. I am not interested in the answer, okay? I keep telling this to everybody and I will repeat myself. I don't care about the answer. I care about the process, how you are solving it. If I get that comfort from you that, okay, my kids are solving it the right way, then only, okay, so this is one sum. Let me put 3 sums here, okay? 12x plus 6x minus 3x equals 75. And third equation is 15x plus 12y equal to 72. Solve this one for x, solve this one for x, and solve this one for x and y. I want you guys to solve these 3 questions, find out the answer, and then let me know once you're ready. Yes, Amoga?
Do you have to solve the equation with how you do the method?
Yes. So I have given you guys 3 equations. This is one equation, 6x plus 12 equals to 24. So solve it for x and tell me what is the value of x. Second equation is 12x plus 6x minus 3x equals to 75. Solve it for x. And the third equation is 15x plus 12y equal to 72. Solve this for x and y because x and y both are unknowns here. So once you guys are ready, raise your hand, then we'll see. Are you guys feeling that this?
Yes.
Are you better? So once you guys are ready, raise your hand. I'll probably take answers from 2 or 3 of you, not everybody, and then try understanding what is the approach that you have taken. That's the most important thing for me. Okay? I'm reading the question for you guys. 6x plus 12 equals to 24. That is the first equation. 12x plus 6x minus 3x equal to 75. That is the second equation. So this is first question, this is second question, and this is third question. It says 15x plus 12y equal to 72. So here you have to solve it for x, here you have to solve it for x, and here you have to solve it for x and y. Yes. Okay. What is the answer for first one?
First one is
X equals to 6. Okay.
X equals to 2.
Okay. Same. How about this one?
Accident.
Okay. So finish it. Okay. So one thing, one recommendation as a teacher, as a father, as an uncle, whatever you call me, is don't compromise on perfection just because you want to be fast. Take your time, do it right, and then we'll increase the speed. Yes. Amoga, you got the answer?
Yeah, for number 1, it's 2.
Okay.
And I didn't solve number 2 yet, but number 3 is 4.
Number 3 is 4.
Yeah.
what here we have equation is 15x plus 12y equals to 72.
It's actually, I actually did.
Okay, so complete it and let me know. Vivan.
Sir, for number one, I got the answer is 2.
Okay.
And for number 2, the answer is 5.
Okay.
And for number 3, x equals 4 and y equals 1.
Okay. So number 3 was a trick question, okay? And if you are solving it, you are getting trapped.
Number 2.
Huh? Number
You
2.
can go number
Okay. Let's see what. Okay. Wait. Let me pay attention to everybody. Yes, Sanvi.
I got 2 for number 1, 5 for number 2.
Okay.
And for number 3, I got x equals 0 and y equals 6.
X equals 0, y equals 6. Okay. Okay. So Sanvi did something interesting. Okay. Third question was a trap. Let me be honest to you guys. Okay. It was a trap. I was trying to trap you guys in that question. Okay. Let's see what Pranav has to say. Yes, Pranav.
For number 1, I got 2. And for number 2, I got 5. I'm still solving number 3.
Number 3, okay, let me just be mindful of your time. Don't try solving number 3. It's a trap. You're not going to solve it.
I already got the answer.
So,
So
Be quick.
X, for first X, it is what? And the second, no, for the
This one is how much?
which one? Number 2 or 1?
Number 1.
That is 2.
2, okay. Number 2,
Number 2, I got as 5.
okay. Number 3.
3, the first X I got as 4, the second is 1.
Okay, so stop it there. Okay, yes.
You just I
Yes.
I'm
Yeah. Now, third question is a trap.
That's not easy.
Third question is a trap. I cannot be more explicit. Okay, I'll tell you why. Let's see Vivan. Yeah, Vivan.
sir, for like a number, I just noticed something for question number 3. There's so many possible answers.
That is why I was saying that was a trap. There are so many possible answers. And what Sanvi tried solving it like the way she will solve a linear equation. Okay, that's what she did. Maybe because she has learned this before. But that is still not the perfect answer, because now let me reveal the trap. If you have to solve for 2 variables, the minimum equation you need is 2. You cannot solve for 2 variables with 1 equation. If anybody says that solve it for this, you are not going to get a perfect answer. Like what Vivan said, you will get so many possible answers. Those are possible answers. There is no concrete answer. So if you need to solve for 2 variables, you need at least 2 equations. At least 2 equations. So if somebody says another trap question saying 5x square plus 6y minus z equal to 45, solve it for x, y and z. You will not be able to solve, regardless of how intelligent you are. Because these are 3 variables. You can find out possible combinations. Okay, if I assume x is 0 and y is 1, then this will be y possible z. But you are not solving it. You are just doing some permutation combination to find some relationship among them. That is not an answer here. So, the answer to what I was saying was, if you have to solve for 2 variables, you need at least 2 equations. If you have to solve for 3 variables, you need at least 3 equations. Just one equation like this will never ever help you solve it for exact value of x, y and z. What is that? We have a lot of time, we learn slowly. So that's what. We are not going to learn everything in one class. Whatever we learn, we will make it ours. We'll make it mine. And then we'll move on to next concept. It's not about how much you learn, it's about how much you retain. Okay? Alright? Everybody is okay? So, now let's do a quick check of what we were trying to do with this and this. So, I know everybody solved it and you all got it right. Okay? There is no confusion about it. But then, I want to emphasize on one thing, which is the way you do it. Math, when we learn, all of here. When we do math is nothing different from how our brain thinks, how we think, how we process it, how we tell a story. So when I'm solving for this equation, I'm not solving it, I'm telling a story. Right? Do you guys see me reading anything? I'm telling you guys a story, right? So here, look at this equation. When I'm trying to solve it, I'm pretty sure most of you would have solved it that way. But when I am solving it, I will solve it like telling a story. 6x plus 12 equal to 24. What I want to do, I want to keep 6x on one side of equal to sign. And everything else move to that side. So, if 24 remains this, whenever I make a plus travel to other side of equal to sign, plus becomes minus, minus becomes plus. Multiplication becomes division, division becomes multiplication. Okay? So here I had a plus, this will become a minus. So far I have not done any calculation, I am just making the numbers move. This is my story. And hence, in the next step, so that means 6x equal to 24 by 12. That is 12. Now, what will be x? Here the thing is, 6x is nothing but 6 into x. If something is multiplied here, if I am forcing that guy to go to other side of equal to, multiplication becomes division. So, if I am keeping only x on one side of equal to, that means I am making the 6 travel. And 6 which was a multiplication here becomes a division here. And then, this. So then in the next step I will say, okay, that means x equals to 2. Or, if you like my style of the game, you will say x equals 12, I will break it down or factorize this, saying 6 into 2 and then by 6. And then I will play with this, tic-tac-toe. Yeah, I have a 2. So, this is my story. What happens is, when you solve it like this, we are all humans, okay? We are very much prone to making mistakes. I am thinking something and I, instead of adding say 24 by 12, instead of saying 12, I make 11. And I wrote 11 here. And I did my solution here. And you will see, oh, I had 4 options to choose from and none of my answer is matching with the options given. That means you have to review. When you go back to your story, you will know, I made a mistake here. When I subtracting this should have been 12. So that is why this story helps you review it. Don't trust yourself too much. Trust how you do things, how methodically you are doing it, how structurally you are putting it in a piece of paper, let me complete. Okay? How you are putting your thoughts while doing the sum. So when you go wrong and when you review it, you will be able to figure out where the problem was, you correct it from there and you get the right answer. Yes, now what is your question? I did not say that. I'll come to TRAN. TRAN is an overall generic concept that some of the new kids don't know. I will repeat that. But here I'm saying, when I'm solving it, when you're solving it, don't assume. See, our problem happens when we assume, oh, I'm super smart, I don't have to spend 3 steps, I can do it in 1 step. You jump from here to here. You ate these 2 steps, thinking I'm smart, and there's no harm in being smart. But then that compromises your ability to review. Because between this step and this step, whatever you assumed, and you assumed it wrong, there's no way you can recover from it. You would not be able to figure out where exactly I went wrong. Because 3 steps you did in your mind, and then recalling that would not be easy. Again, we are looking at very simple sum. Imagine when you are dealing with 3-4 variables, and then you are doing a lot of mind math and not putting it in your storyline. It will be very difficult to review and find out where the problem is. Let's see what Dikshita is saying. Yes, Dikshita.
So, sir, we can't solve the third one?
Here?
Yeah. No.
Third question, yes. Third question we cancelled because that was a trap. I was just trying to trap you guys, okay? Again, when I said it was a trap, I was trying to get that conviction from your side. Meaning, when you try solving a problem, not every problem you have to solve right after seeing the question, okay? If you have to solve, I'll say, okay, solve an equation for 3x plus 2y minus z equal to 82. As soon as you see the question, first thing that will come to your mind is, somebody is asking you to solve for x, y and z, meaning 3 variables, with only one equation. In my lifetime so far, I have never solved it for 3 variables with one equation. This question is incomplete. I need at least 2 more equations to be able to solve it. So that is where you will stop. So that's what I was trying to, by saying the word trap so many times, I'm actually forcing you to believe that if you come across a situation like this, first thing you will see, okay, how many variables, how many equations. If I have one variable to solve it for, like this one, with one equation, I'm good. I can carry on. If I have to solve it for one variable, this is x and x, meaning one variable only. I have to solve it for x, only one variable with one equation. I'm good. Now I can put my effort in the right direction. Here, what will happen is you are trying to solve for 3 variables with one equation. Your effort is going to go down the drain because you will not get the solution. And that is where it's very important to make those smart moves. When you are in the examination hall, let's say you're dealing with 20 questions, you would not want to get stuck on the 5th question and get a 0 on remaining 15 questions, right? You would want to see what are the questions that I can solve quickly, let me solve them, and then I will see how much time and energy I am left with for doing the ones which are difficult. Because you certainly want to score in all the questions that you already know. Yeah? So here, when you look at this question, you will simply say, okay, fine, this doesn't seem to be an easy one. I'll come to this later because I'm not seeing a problem getting solved with 3 variables in one equation. Yeah? Alright? So that was the reason, Dikshita, okay? Now, again, I might end up spending another 2 hours, or I might end up wasting your 2 hours emphasizing the fact that when you are solving an equation, solve it like you are telling a story to somebody. Always. Even you guys are 1/3 of my age, for sure. No, even less than that. But still, when I am doing it, I have dealt with this kind of equation maybe 1,000, maybe 5,000 times in my lifetime so far. But then, when I am doing it, I am still doing it like a story, step by step. Because that is what I have gotten used to. I want you guys to get used to it because it will be of great help. It doesn't take time. It doesn't really take time, trust me. It just helps you do it right. If you jump from here to here, you're still thinking in your mind, and maybe you'll take 2 seconds. If you do this whole thing, you might take 4 seconds. You're just spending few seconds extra, maybe a minute extra. But then, if you make a mistake somewhere halfway through, you have an opportunity to go back, review and fix it. This is what will help you with the review. Don't ever assume that you solve a question from beginning to end and you'll be right always. Nobody is right always. Huh? That is where you go wrong. Don't do that. It's a learning, trust me, beta, it's a learning. I'll be shameless in acknowledging the fact that even in the class when I'm teaching you guys, I've gone wrong so many times. I've gone wrong many times. I'll acknowledge that. And that's quite natural. It happens, it's just a calculation. I get a little distracted, I assume something and I'll go wrong. But then if I'm writing it like a story, I have an opportunity to come back. I can review. And that is what you all have to practice, because in the exam, when you're solving any equation, solving problems, you certainly want to do it quickly, do it accurate and save some time for review towards the end of the exam. That's a very good practice. At least, let's say if you're solving 50 problems, 5 problems where you have doubt, at least mark them. Okay, these 5 questions I will come back to, just to make sure that I have done it right. Okay, so that way, out of 5 questions which could have gone wrong, if you even correct 2 of them, you are improving your chance of getting better score. Okay, so that's why review is very important, and this approach of writing story, going step by step, it will help you do this. That's why I'm emphasizing on this one. Trust me, there is nothing for you guys to learn. It is more about doing it in practice. So when you're solving it, write it clearly, write it step by step. Don't jump 2 steps thinking I'm super smart. Okay? Yes, Dikshita.
Is there a particular formula for this, sir?
No formula. Just go step by step. Don't do 2 calculations at the same time. Okay? Now, I'll give you an example here. So look at this. We all know our brains. We all know how our brain works, right? Our brain, if you ask me to teach math and science both in the same class, do you think I'll do a good job? No, I will not. My brain is only tuned to teach one thing at a time. I can only teach math right now. I cannot do math here on one board and science here on another board. I'll be messing up big time. That is how the brain works. It goes in a sequential manner. For people who know programming, it's a monolith program, okay? One step-by-step process, that's what it follows. Now here, don't go into monolith, just go look at this program. Here, what is that you are doing? If you look at this equation, okay, we have solved this one, let's go to the next one, okay? Now let's try solving this one. I have 12x, 6x, minus 3x equal to 75. So I have all the x's on one side. What is that we have to do? We have to add and subtract them together and see what is that. It's like 12 bananas, 6 bananas, 3 bananas. That's what we have here. So 12x plus 6x gives me 18x minus 3x equal to 75. What did I do here? I did the addition here only addition. I did not try to add 12 plus 6, 18 minus 3, 15x. I did not do that. I just did addition here. Now, I'll do the next operation in the next step. So 18x minus 13, 3x, 15x equal to 75. What did I do? I did subtraction only. So, to your point, Dikshita, you can even think of doing one operation at a time. Don't do multiple operations at the same time. That might help you, keep it straight. Now here, now I have 15x as in 15 into x. So I am doing the multiplication side of things. If I just keep x on this side, that means this one, it will become divided by. So I did not do the calculation here, 75 by 15. What I did was, okay, I first got what is that, I have to solve it first. Now my next step says, okay, that means x equals, let's break it down. This becomes 15 into 5 and this becomes 5 into 3. I'll do tic-tac-toe. Now my x says 15 by 3. We know for the matter of fact 15 is, if I can factorize this further. So x equals to 5 into 3 by 3. I can do tic-tac-toe one more time. Yeah? So, very simple. One operation at a time. One thing at a time. Like I tell you guys, right? If you are in the class, I need your undivided attention. Meaning, you are only learning math at a time. You are not trying to do debate with me. Careful. You are not trying to see what is happening on the road. You are not trying to be concerned about what is happening in the kitchen, what is there for dinner. Yeah? You are not even worrying about, will daddy take me out for ice cream because Sunday today. Yeah? So what I'm saying is, just one operation at a time, one thing at a time. That is what will help you make sure that you stay focused. And if you go wrong anywhere, you would know at what step I have gone wrong. Is that clear? Who was smiling about the ice cream? Who all goes for ice cream on Sunday evening? You guys go out for ice cream on Sunday evening now?
We actually get
Okay.
And we also get new math worksheet every week Sunday. Not
What is that? Your parents anniversary today? Good that you reminded me, I'll wish daddy.
You didn't know that?
I didn't know that.
You need I don't do math.
Okay. All right. So, yeah, somebody was raising hand. Okay. No questions? Shall we move on? All right. So, this is one of the biggest learning I would want you guys to keep with you. Okay. We still have 10 more minutes. Now, let's look at solving one more problem. I was telling that if I have two equations, I can solve for two variables. Let's try getting our hands dirty with that. Let's say one equation is plus 2y equal to 17 and 3x minus y equal to 82. Now if somebody says solve it for x and y, this is doable at a high level at least. Because by looking at the question, I am convinced that okay, I can put the effort to try solving it. Because I have two equations and I have two variables. Yeah? So what I can do here is, let's find out the value of x in this equation and substitute here. Or find out the value of y here, put in this equation. That is how you will go about solving it. Okay? So let's try doing it. Now let's look at this is equation 1, this is equation 2. Okay? This is not question 1 and 2. Okay? Equation 1 and 2. Now in this equation, let's come to this one. X plus 2y equal to 17. Let's find out what will be x. X will be 17 minus 2y. It's a plus here. I'm making this guy travel to other side of the border. This plus becomes minus. So I got the value of x as 17 minus 2y. This is the best I can do with this equation right now. Okay? I'm not able to get the exact value of x. Now what will I do? Now since I got the value of x, let's put that value here. So 3 into x minus y equal to 82. Now in place of x, I will put this value now. 3 into x is 17 minus 2y minus y equal to 82. This became my new equation by substituting the value of x from this equation into this one. Are you with me? Now,
Yes, sir.
this is my equation and let's try solving this. And this is just again the same punchline. We are still just scratching the surface. There is lot more. Now I got 3 into 17 minus 2y minus y equal to 82. Now let's break the bracket, right? That's why PAMDAS or BADMAS says, right? If you have to do operation, you will first break the bracket. It starts with bracket. So I'm breaking the bracket right now. 3 into 17 gives me 51 minus 3 into 2y. Okay, I jumped one step. Let me not do that. I'm breaking the bracket. This is what becomes minus y equal to 82. I did not assume anything. I did not act smart. Yeah? Now, 3 into 17 gives me 51 minus 3 into 2y. 3 into 2, 6. 6y minus y equal to 82. Okay? Now, similar things will add together. So 51 minus 6y minus y. So minus 6y and minus y becomes minus 7y. Yeah? You guys are clear about that one? Okay. So minus 7y equal to 82. So this was like, this much I had borrowed and this much I also had borrowed. This is my total debt. Negative. Okay? So 51 minus 7y equal to 82. So now let's put y on one side and numbers on the other side. So let's make this number go other side. So minus 7y equals 82. Here it is nothing but plus. So it becomes 82 minus 51. So minus 7y equals 82 minus 51 will be 29. No, sorry, 31. Yeah. So y will be equal to minus 31 divided by minus 7. So again, this was just an example. I was just telling you guys, if you have two equations, how do you solve for two variables? What you do is, you find out one variable in terms of the second variable first and use that value to substitute in the second equation to solve it. This doesn't matter. I don't care about the answer, as I say, right? So I'm saying this is one way of solving it. Okay, there are many other ways to solve the equation. Okay, let's park that understanding for now. When we look at other methods, then you'll have few choices and you can choose which method you like. And that's the only method that you will keep it yourself. Okay? That's fine. Yeah? So far, we just have 5 more minutes. So I want to stop here and do a quick recap of what we have learned so far. So we did a recap of what is equation, expression and inequalities at a concept level. Then we looked at what are the monomials, polynomials, binomials, trinomials, all those meals, right? So that we learned and looked at the conceptual part of it. Then we started looking at solving equations. So far we have solved 2-3 equations with one variable. And then we just looked at one question where we have to solve for 2 variables with 2 equations. Our main takeaway right now is, if I have to solve for 1 variable, then I need 1 equation. If I have to solve for 2 variables, I need at least 2 equations. If I have to solve for 3 variables, I would need 3 equations. Or in generic terms, I can say I would need as many equations as I have variables to solve for. Done deal. That's where we will stop for today. Any questions, anybody having any doubt you have before we say enjoy the rest of your weekend? No? I can say enjoy your weekend.
How old are you?
Who, me? I'll not say that.
Why?
No, you can count the number of grey hairs I've got. I'm not very young anymore. I'm pretty old. My daughter is going to go to college soon.
45?
More than that. Okay?
50?
Not yet. Okay, you got arranged. That is what is called a histogram. When you have to plot a graph, based on a range, we'll learn about that later. Okay? So just I created the curiosity for you. What is a histogram? When you are plotting a graph with a range. When we come to that, then we'll talk about my age. Okay? I'll disclose my age that day.
Yeah.
Alright. So that's all for today. Are we good? Everybody good, ready to rock and roll for this weekend? I know you guys have one more weekend before your summer break ends.
Let's go.
Oh.
School. Yes.
Yep. Alright. So enjoy the rest of the evening and see you guys on next Saturday. I'll upload the video by tomorrow and send you guys the assignment soon. Okay? Alright? Have fun. Alright. Bye-bye. Bye-bye.
Thank you, sir. Bye.
Bye-bye. 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 Bye-bye.
You need them to go.
Okay. Hi, Aditi. Huh?
Sir.
Hello, Beta. How are you?
Hi.
Hello, Beta. How are you? Good? Good. Alright, yeah, you're saying something.
I need a ruler.
You need?
A ruler.
You need what?
A ruler.
Ruler. Ask your daddy.
He wants to smash my knuckles. We don't do it like we do.
Okay. So Aditi, you are 2 minutes early. We'll just give 2 more minutes to other kids to join and then we'll start, okay? Till that time you can just settle down, take a chill pill, have some water. If you want to take a bio break, go ahead. Yeah? Alright? So just 2 more minutes. We'll let everybody join and then we'll start. So don't get very aggressive, okay? It'll hurt.
Yeah, but this is better than this.
It's okay. It's fine. Kadu.
Give it to us.
Yep, yeah.
This is like geometry notebook to use. Doesn't matter.
You guys, no, it
You have
doesn't.
such dirty handwriting.
Doesn't matter, I'm saying. So it is always up to us how we want to use our time. Do we want to waste our time fighting or do we want to use our time learning something?
See, and look at my handwriting. Look.
Okay, everybody inside, till your parents are here. Okay. Audrey? Please stay inside here. Because I'll drop in shot, I'll not be able to see the voice later. Sit down, sit down, sit down, sit down. Sit down. Go sit down. Sit down, sit down. Now the kids are joining from the next class, so I would want. What is that?
Wait, do you have a silver play button?